Alright, so what we're going to be looking at is our review for our Unit 4A quiz. Now, we need to know a lot of key vocabulary words here. One of them being, what does the word roots mean? Another word for roots are zeros. Zeros of the quadratic function. We also need to know that a quadratic function, so a quadratic function is of degree what? Good. It's of degree 2. Now what does that mean, of degree 2? The degree means the exponent, the highest exponent of the graph. So something like this would be quadratic. Something like this would also be quadratic. However, if I had something like this would not be quadratic because the degree for this one would be 3. Okay, so now that we know really the essentials of a quadratic function, that it has to be of degree 2, now we're able to take a deeper look into the roots of a quadratic function. Alright, so the roots or the zeros of a quadratic function means that y has to be equal to 0. So we are going to analyze where are the x values where y is equal to 0. So let's take a look at our first graph. Alright, so on our first graph, we are looking for where y equals 0. Let's see. If I were to draw in a dashed line, that's where y is equal to 0. So where y is 0, our x values that cross are right here and right here. That's when x equals -1, and this is when x equals 5. So the zeros for our function here would be at -1 and when x is equal to also 5. Okay, next we have our table. Again, we need to look for where is y equal to 0. We need to find where y is equal to 0. That's defined as really finding the zeros or the roots of a function. Okay, so where y is equal to 0, well, that's here and here. Be careful, this is not a root. This actually right here, anyone know what that would actually be? This would be our y-intercept. So our roots again here are at -1 and 5. So we have x equals -1 and x equals 5. Alright, moving on. Okay, lastly, we need to look at the following. We have 3 and 4 left. Again, we need to know where is y equal to 0. Well, if I look at answer choice 3 here, I have x equaling 0 and x equaling 0. That is no good. That's no good. I want where y equals 0. Well, here, for answer choice or part 4, I have y is equal to 0 and y is equal to 0. Again, giving me x equal to -1 and x equal to 5. So now let's look at our answer choices. The question says, which of the following have roots at x equaling 1 and when x equals -1 and when x equals 5. So we already did this. It's going to be 1, it's going to be 2, and it's going to be 4. So our answer here is 3. All right, great. Let's keep going. All right, next we need to look for the axis of symmetry. Again, another key vocabulary word you need to know. So the axis of symmetry, the equation for this is we have x equals -b over 2a. Your answer is incorrect if you only write -b over 2a. If you only write this, that's wrong. You need the entire thing. You need x in there as well. Okay, so let's break down the quadratic. So I have -x squared plus 4x minus 5. Well, I have to look at the number out front. If I were to write out what a, b, and c are, first I have to check, is this in standard form? Yes, it is. We have -x squared, so the squared. This is technically being raised to the first. And this has no x value. Really, this is x to the 0, but we don't worry about that. Okay, so this is a quadratic. The highest degree is 2. I want to find the axis of symmetry. All right, well, I know A is going to equal -1. B is going to equal 4. I don't care about C when it comes to the axis of symmetry. Now I'm just going to plug in as normal. We have x equals negative, we have x equals negative b over 2a. B is 4 all over 2 times -1. When you put this in the calculator, you get x equals -4 over -2. X equals 2, and we're done. That's how we algebraically find the axis of symmetry. And just very quickly, I will give you the results here for this one. For x squared minus x minus 6, we know a is going to equal 1, because there's a 1 out front. We know b is going to equal -1, because there is a -1 out front. Same thing, you have x equals negative b over 2a, and you're just going to substitute in. Alright, this next part for matching the graph to the equation, guys, all you have to do is literally just graph this and see what it looks like. Just graph it and see what it looks like. Okay? So this part I don't think I really need to go over. If you have questions, you can just shoot me an email. But again, you just need to put all these in the calculator and graph them. There's just a little typo here. You don't need that 4 there. Okay, so you're just going to graph what happens with each one. You should have an idea. Because the number out front of x squared is positive, that means this is going to open upward. Okay, this is going to open upwards. These two here have a negative out front of the x squared. So those are going to open downwards. Okay, so the first two are going to open upwards. And then the second two are going to open downwards. All right, next up we have average rate of change. You need to know what this word means, guys. You have to know average rate of change by this point. This is on every single Regents exam, and it will be on your quiz tomorrow. Average rate of change represents slope. You need to know what the formula is for slope. We have slope equals y2 minus y1 all over x2 minus x1. Now, we need to use the given interval to figure out what the rate of change is. And I'm going to also show you a little shortcut as well. But let's go doing this algebraically, because a lot of the times, too, the Regents ask for an algebraic solution. So let's see. I'm looking for when x is between -4 and 2. Now, you have to remember, guys, from class, if I give you an interval, we are only using the endpoint values. So I'm only going to use -4, that's x1, and then 2, that is x2. Again, when I give you an interval, you only use the endpoints. Do not use the numbers within the interval, just the endpoints. Okay, I'm going to create a table here. So I have my x values and I have my y values. I know x1 is -4. So I'm going to write that on the side. And I know x2 is 2. Write that on the side. All right. Now, guys, you need to use the graph. It's given to you for a reason. We have to look. When x is -4, what's my y value? So when x is -4, go all the way over to -4. Up, there it is. There's my y value. My y value is at -1. So I'm going to put a point there. -1. My x value, so again, I'm going to come all the way over to when x is 2. I'm going to travel all the way up to where it touches the graph, and it's right there. So it's right on 5. So when x is equal to 2, I have y is equal to 5, and I'm going to put the point there. These are my corresponding values, guys. Here's my y1, and here's my y2. I just need to fill in the formula now. Now this is a piece of cake. So slope is going to equal y2 minus y1. So 5 minus -1. You need the parentheses. All over 2 minus -4. When I put this in the calculator, which you should be doing, you get 6 divided by 6, which is just 1. So the average rate of change, or the slope, is equal to 1. Now, very quickly, I'm going to show you guys a very quick shortcut if you were to do this graphically. So if we were to do this graphically, guys, think about slope. It's rise over run, right? I'm starting here from this point, and I'm ending at this point on the graph. So let's look at rise over run. Rise up one, over one, 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 up one, over one. Okay, if I were to connect this with a straight line, okay, if I was using a ruler, oh, that's terrible. If I were using a ruler, pretend that's a straight line. What's the slope? As I go from -4, -1 to 2, 5. The slope, guys, if I look at rise over run, it's equal to 1. So guys, that's it. Here's your algebraic way of doing it as provided here. And then graphically, this is the work right here. Rise over run, that's it. Alright, so very quickly I'm going to go through a few more problems over here. So standard form, we already talked about this. You need to have the highest degree, so the highest exponent out front, and then going from highest to lowest order. So we're going to rewrite this as -x squared plus 6x minus 1. For the second one, again, we need to go in order. 3x squared will be first. Next is my -x, and then my -9. This is in standard form. Lastly, I have -6x squared plus 2x plus 10, and that's it. We're done. It needs to look like this, guys. ax squared plus bx plus c. Alright, so for the questions that ask about points on a graph, you want these questions. Because why? First off, all 4 answer choices are there, so it has to be one of them. I give you an equation. You need to use your calculators. You need to go into y equals on the calculator and graph this. You're going to go to your table. So we're going to go second graph to get the table. Second graph. To get the table. The table of values will tell you which of these points is going to be on the graph. This ended up being a repeated answer, so you can ignore answer choice 4. So really, you have it down to 3 answer choices. So you need to look at your graph and see, when I check out the table, which of these points is on there. Now, say you're having trouble with that. Guess what, guys? Here's x, here's y. Here's x, here's y. Here's x, here's y. Plug it into your plug it into your equation if you're having trouble with this. If these points, when you plug it in, satisfies the equation, you know you did it right, and you can give yourself a check. Alright, so that's the case for questions 1, 2, and 3. I'm not going to really go through this because you have a calculator and you can do this. Do this on your calculator. I will post solutions later tonight on my answer key for this. Alright, last but not least, the graph of a quadratic function. Well, again, a quadratic function has to be of degree 2. Okay, degree 2, it looks like a parabola, which is what we have over here. Okay, I have a parabola. Alright, again, that would look something like ax squared plus bx plus c. You need it to have degree 2. The exponent, the highest exponent being 2. Okay, we already talked about this. What's another word for roots, guys? Good. Okay, another word for roots are going to be our zeros. But what does that mean? Our zeros. We are looking for when y equals 0. So if I were to look at my graph, where does y equal 0? Well, let's check it out. Here's where y equals 0, and here is where y equals 0. You need to tell me those corresponding x values. Well, here and here, I have x equaling 0. And here I have x equaling 4. Alright, so my zeros are going to be x equals 0 and x equals 4, and that's it. Now, another word for vertex, guys, is turning point. Turning point. So that is where the graph changes direction. So if I were to look at the graph, the only place it changes direction is here. At the point 2, negative 4. So again, the vertex is equivalent to the turning point. Vertex is equivalent to talking about the turning point. All right, so the turning point, I'm just going to write this in just so you have it, is going to be 2, negative 4. All right, next we have to look at the axis of symmetry. Now, guys, this is really important. When you're talking about the axis of symmetry, that is a line. The axis of symmetry refers to a line. That's going to be symmetric of the parabola. So I just sketched in for you. I highlighted over the axis of symmetry. I'm going to write x equals or y equals, guys. It's a line that is vertical. Again, it's a little counterintuitive. But this is actually going to be x equals a number. And x is going to equal 2. So our axis of symmetry is that x equals 2. All right, let's finish it up here. We're almost done. Domain and range. You need to know domain are your x values and range are your y values. Okay, well, let's see. What are all the possible y values for this graph? Okay, what are all the possible y values? Well, I'm going to sketch over this. Let's do this. Here we go. There's my parabola. Okay. What is the smallest that y can be? What's the smallest that y can be? Yeah, if we look, the smallest that y can be is at negative 4. That's the smallest y value. And what's the largest that y can be? Let's check out our graph. Let's see, it keeps going, keeps going, keeps going, keeps going, and going, and going. The largest that y can be is going to go all the way up to infinity. So when I look at this graph, the range is actually going to be all values that are at least negative 4. So my y values are going to be when y is greater than or equal to negative 4. And also, guys, domain, whenever I'm talking about a parabola, the domain for any parabola is going to be all real numbers. That's your answer. Domain for a parabola is all real numbers. It goes in both directions forever and ever. So this is going forever and ever to negative infinity, and this is going forever and ever to positive infinity. Alright, guys, well, I hope this video was helpful. Best of luck as you study for your quiz. If you have any questions, please feel free to email me or contact me on the Remind app. I hope you have a good night. I hope this video was helpful. Leave a comment and like and subscribe. Alright, guys. Good luck. You're all going to do great. See you tomorrow.